Jai Hind to all. My name is Aarti Chaudhary and I'm the assistant professor in IT department. So today's topic is application layer. As we know that the application layer is a foremost layer where we start with sending the data. As we know that in a computer networks, the application layer is on the top of the layers. Then after the data will be assembled from the application layer, goes to the network layer, physical layer, data link layer, and end with a physical layer. Then on the at the sender side also and the receiver side also, it will go like this when the data is accepted at the physical layer and then goes up to the application layer. So what is the application layer? Where the sender will start the data. So how will the data packet is assembled in the application layer? What are the things? This is a raw data will be sending over. So in this layer, we will go for many of the application, many of the protocols which we use in, that is DNS. What is DNS here? What is URL? How the DNS architecture is there? What is the DNS working is to be there? All the things we will discuss in our lecture. So the points to be discussed in the PPTs are to be DNS, that is domain name system, a domain namespace also. What the architecture, what is the working of it, how it's working, because we know that we can't remember. We have seen that the network, in the network layer, which is having a IP address. We know that that is a IP address that is of how many bits? That is of 32 bits. Okay. So that is, for example, 10.7.7.16 is our IP address. But we don't know the actual, we can't remember it because there's many sites on internet and we can't remember the IP addresses. So what the solution is coming to? That solution is come by a DNS. DNS will provide you a unique name of it and you will remember it, because as a human we can't remember the numbers, because 10.7.7, if other one have written 17, so it will not go to that site, because in the internet what we have is we can't remember the IP addresses. So we will remember the strings, alphanumeric, this is google.com, yahoo.com, gmail.com, any site your friend will suggest it, any site for the in a discussion or in anything, any website. So we will remember the website name, not the IP address, but the behind the picture, that IP address will come into picture. So we have seen the IP address in a network layer that is of 32 bits, which are having a 8888 octet into it. So we can't remember it. That the solution comes to it is a DNS server system. We are having a server also having what is the architecture of it, how it's working. All these servers have a root server also, primary server also. We are having a secondary server also. If we are not getting a IP address on the root server, it will search on root server. Then after it will go to secondary server, because all these are stored into a cache. If we want to do is, for example, www.google.com. So we are having a category of it. .com will go to a .com server. Edu will go to a edu server. Government will go to a government, because we are having a lots of. So we will see that we will divide it into according to a zones also. Because we are not having a centralized, we are using a distributed system into it, distributed architecture. Small files are here into this server, distributed server, other is on other servers. So we are not using a centralized servers, because we are periodically have to create them also, update them also, delete them also, because if the website is not longer, we will delete it also, because we are not overloading it. overloading the servers, because daily basis pay we are having a many of sites are updating, many of our IPs addresses are making. So we are just taking a current website which are used into the current scenario is updated and creating it. So we are having this outline of my discussion with the architecture and how they are working for it when we are requesting for any IP address, and then we are requesting for any page to come, so how the DNS will work behind the picture, and what the URL, we will touch also the URL also. So what the first thing is, when the DNS is not into existence, when we are not having a DNS, the first thing is we have to remember the IP. As a human, we can't remember the IP, because as seen we in computers also, we will not remember the IP address, ASCII codes. We will remember that A, we know that A, this is A, this is small a, we know that this, but computer is what they are converting it to a binary form, IP zeros and ones. That is done by the behind the picture. But so as a human, we can't do it. So DNS, so the restriction is DNS is not into picture. So what we have to download a file that is having a host name and the host file which are having a corresponding. So that file is containing a host file. Every that file is having a host name and corresponding uske addresses. So for example, google.com address is there, yahoo.com address is there, google gmail.com address is there. So we are having a IP. But as a digital scenario, we can't have to have the file is so long. So as in increasing, the problem arises when we are increasing in our number of hosts into our user. But when we are having a limited user in 17 and 80s, when the internet is started, it is okay with us to we have a host file with us. But when the numbers of hosts is increasing, that the file is also increasing, that resulting that we can't download it. So we introduce and our solution of this is DNS server. DNS server system will use a mechanism to make that when we are, because we are a human, we are not comfortable with zeros and ones, we are not comfortable with remembering the IP address and method. So that thing is decided by, that thing is used by our DNS is to be the DNS server. Okay, so this problem, so DNS come into a picture. The DNS help to resolve a host name to address. We are having a host name, for example, www.google.com. It is corresponding with an IP address that is there. So it is using a hierarchical name. That is, we see that in a form of hierarchical, that is subtree, tree, root node, sub node. These are the structure to save our DNS here, and that is the first one is hierarchical in the form of trees we are forming, and distributed data system, not centralized data system. We can't make it a centralized server and all the load is to be there. So we are making our servers according to the .com, .edu. I will see you that the namespace we are having. So we are having a distributed database of the IPs and associated names. We know that IP is of 32 bits, we know that. Well, in a network layer, we have seen that. IP version 4 we are using here. Right now also we are not upgraded to a version 6 also. While on the other hand, the domain name is easy to remember. We will remember google.com, gmail.com, yahoo.com. We will remember it, but we can't remember the IPs of it. So that is taken care by the DNS system. For example, we will enter any email address while using a string. What will we say? Aarti@yahoo.com. We will write. We will not see the .com part, what the IP is assigning to it, we will not see. There's in a college also website, we are having Chaudhary, Aarti @AKGEC.edu.in. We are having that part also. So that part also, this is assigning. We are having a string value, that is symbolic and string value, which is easy to remember us, but we can't remember the IP which is giving behind it. We will not. So that is taken care by the DNS server. So we will see that the architecture, first we will see that the architecture of this is comprised of three parts, that is DNS, domain name, domain namespace, DNS, and name server. Three part we are having is domain name, domain namespace, and the name server we will hit. So we will go for a domain name. The domain name is a string, symbolic string associated with IPs. So string with associated with IP. So we will have a, for example, www.yahoo.com, which is having an, for example, an IP of this associated with it, default IP, because the IP has to be two parts. When we see in a network layer, the IP has to be permanent also, and when we are using it, for example, we are a temporary user, we are connected to an internet, we are connected to with an IP that is temporary. But yahoo.com, google.com, they are purchased an IP address, and that is static to them. But when we are connected to our internet, we are having a dynamic IPs. So for example, if I connected today, so I get other IP. Because I'm not purchasing it. When we are IP is static, that with big servers, big companies as Yahoo, Facebook, Instagram, Yahoo, they are having a static IPs. That IP is fixed. Every time you will call them, the IP address that is fixed to them is to be called them. So for example, any address, IP address that is 192.168.170.117, so that is a IP called by the Yahoo. That is not used by any other of the in the world also. That the IP is not used by any other of the server, any Yahoo, if Yahoo is using, because they are paying for this. So we are having a two IPs also, that is static IP and dynamic IP. But as a temporary user, we are using it when we are connected to the internet, and when my system is online, so we are having a dynamic IP there. That is, every time we are getting it, new IP we are getting it, and that is it, if we want to track it. So this is a static. So the big servers, big companies are purchasing a static IP. The IP will not change. Every time you will ping them, every time you're requesting the server to download a page, google.com, yeah, do Google Pay, you will write something like DNS server, you have to read something, your any page, requesting for the page. So that IP, the first page we will opening, the IP will be static, and that static IP will be assigned to a server which is used, which is purchased by that server. Okay. So the domain name is a symbolic string associated with the IP address. Several domain names we are having, that is, we are having a .com also, edu also. .com is commercial sites also, education sites also. We are having a government site also. So every having a domain name of it, because we will categorize. For example, we will ask for www.yahoo.com, it will go for a commercial domain server. If we are saying for www.akgedu.in, we will go for education websites. If we will go for www. Any government site, that's for example Aadhaar card website, we will go for .gov.in. So that will go for a .government server, .government domain server, and it will go that way, and the IP will be assigned. So in the previous slide also, the has to be, the domain name system is using a hierarchical, that is a tree forming to it. Some is a country website, country level website also. These are the, within a country there is a .com also, edu also, government also, net also, networking websites also. But when we are going for government, that is country level, that is Australia, we are having India, UK, Germany. So every site has to be .in. When we are written in, that is in India. .au, that is in Australia website. Because when we are using any product, so we will see that, for example, we will go for a shopping. So India, Amazon have a website for India, Amazon has a website for UK, Amazon has a website, because they are having a different constraint, they are having a different feel out websites, and different discounts and different categories, and different according to their need they were categorizing it. So when we are in which country you are having, that website, that domain name has to be there. So in India, IN is referred to India, we are having it. So these are the top level domain name. We are having a commercial.com, we will use a commercial business. Edu is for education websites. That is GOV, that is a government websites, agencies we are having. INT is international entity. IML, that is US military we are having. ENT, that is networking organization, and ORG is non-profitable organization. If we are a government.org.in, that is government website, and it is non-profitable organization and is in India. So like gov.org.in. So this is government, this is non-profitable, and this is in India. But if it written that government org in UK, that is in UK website we are having. Okay. Then we are having a country level also, that we are having Australia for AU, India IN, CL for Chile, France for FR we are having, that is US for United States, ZA for South Africa, UK for United Kingdom, this for Japan, and ES for Spain, EDU for the German, CA for Canada, E for Australia, and this. All these are the extensions we are using for our domain namespace at the country level. Okay. Next, we have domain name at the country level also, and the level of the government commercial websites also. Okay. Then we are having a domain namespace. In domain namespace, we are having a top to level, meta hierarchical form. We are hierarchical of internet structure, and we are hierarchical of the multiple levels from the 0 to 127 level. Only 127, 128 levels we will have it. From top to bottom we are having it. Root at the top. Okay, this is down this. So this is a diagram for the sub imagine. This is hierarchical. We have seen that hierarchical. This is the top level. In this we are having es.com, government, edu, org. We are having, but in edu there is any website that is of which field? Education field, that is called row. In that cold row, there was any CS branch, that is computer science also. So computer science, we are having any Maria, या Roxy, या Kim. So we will see that Maria .cs .edu in which. So this is a hierarchy we will mention. We will go from bottom to top. That when we want to search, when we will write it, Maria will upper go in up cycle, up tree, then we'll up tree, and then we up tree, and this is merger. This is my root tree. Okay, so this is my Maria. If I want to write Roxy, we will replace it by Roxy, and it will go to a roxy.cs.colorado.edu.in because it is India. For example, we are considering for India. If it's not in India, so you will write it UK also. Any term you will replace it, it will divert to that path to it, because the IP is different, IP address is different, because we have to DNS will map. What will we write it? It will map into a DNS server, and then after the requesting IP to it. That is a whole process. You will write it www. For example, tutorial point, yeah, any I mean Greek.com. So you will request it and the DNS will understand, okay, that IP. So you will write a .in, so it will go to a Indian server. If it's not, so it will go to a UK server, and you will write it. What will you write it into a DNS? So you will get a IP according to it. So this is a hierarchical form. We will have it, and we are having a category of it: ES also, .com also, government also, education also, non-profitable also, commercial sites also. So you will write. So it will it will go a root domain server, and then after it will go to a if it's not finding into it, it will divert into a .com server, .com root server, yeah, .com education server. It will divert into a that domain server. Okay. This is a namespace. We are having a namespace because we are having a database on database server. The namespace, जो namespace servers होते हैं, that contains a DNS databases. These databases have various names and their corresponding IP address, because we have the main motto of DNS is to, when we are writing a string, you will give a IP address back to it. If it's not maybe it's not possible for a single server, because I've seen that we are using a distributed server. The way we are not having a single server to maintain this. So we have an entire DNS database, DNS databases. Therefore, we are using a distributed approach. Distributed is what we are having here also. We are having here also. We are having here also. We are having here. So if it's a nearby server, we will request it and we will get a IP address, not a centralized one. So in the centralized, what we are having, only this point. So what is the disadvantage? If this fails, my DNS is gone. My DNS is gone. If I'm not getting an IP address, we are not up into our internet. If we are not into our internet, and then after, everything is zero for us, because we are living into a digital scenario. So we can't come with us this solution. So we are having a solution of distributed here. So hierarchy of servers is same as a hierarchy of names. What we are using, we are having a tree structures, subtrees. So with the entire name, we are dividing into zones. Because we are entire world, we are dividing into a south zone, north zone, east zone, east-west zone. We are dividing according to that. So the thing is, that comes into picture is to a zone. The zone is a collection of nodes, that is subdomains under a main domain. So we are having a main domain and we are having a subdomain also, subdomain 2 also, subdomain 1 also, subdomain, and up to n we are having a domain. Okay, the server maintain a database. Every server will maintain a database called a zone file for each zone. We are having a each zone. The zones are coordinating with each other, because every zone have a file. That file has to be update also, any creation also, any deletion also. So that thing has to be coordinated between. So this done by our distributed databases, that is a coordination between these zones. Okay, these files are to be. So this is an example of the zone we are having. We are having a edu zone. In edu zone, we are having 2 EMU and CENFORT. Okay, when we are having Berkeley edu zone, we are having CO or ME also. In that, we are having a CS department also. So we are having a CS and a subcategory also. So what we are having is, we are dividing into a zones. That edu zone, first zone, that is a main domain. Next is subdomain is the Berkeley edu zone, and then CS edu zone. For example, I will say that it will AKG, then AKG में IT department में second year. We will see that. So that zone has to be divided. If it's on the large scale, so we will divide it in AKG, then we are going for a IT department. IT department, we are going for the second department, second year also, third year also, fourth year also, IT department. If we go for this, then there were also other departments also, that is also CS also, CSIT also, and IT, CSIT, CSML, and all that stuff. So we are dividing according to a zone. So this is our main zone, and these are the subzone. But there have to be a coordinations, because this is divided into hierarchy, and hierarchy has to be followed, and hierarchy may that zones have to be coordinated to each other for the updation and all that. So all the domains, if its domain is not divided into a subdomain, so we will say that it is a main domain. That in AKG we are not dividing into ITs and all that. We are just making a AKGEC.ac.in. This information about the nodes into a subdomain is stored into a server at lower level. So lower level will save that into a database, but the original server kept the reference of these domains. So when we are having a data here saved it at the image, but the reference has to be saved into a main server where the things, all the things has to be saved. But at the lower level we are having it. Okay. Next, we are having a types of the name servers that we are having. Three name servers we are having: root server, primary server, and secondary server. All servers are coordinating with each other. And this server is coordinating with this server is coordinating. So there was two-way communication between these servers. But the request when we are having a DNS server will go into a DNS name, then it will go to a main server. Okay, so what are the server? We will see that the top, that is a top level servers, that is a root server. Root server is at top level. It consists of entire DNS tree that is on the root, because it's on the root and there was a secondary and primary at this. It doesn't contain the information about the version, because it will direct it into a secondary server, .com server, yeah, .edu server, .gui server, but the delegate of authority to the other servers. They will making a servers, other servers also. Okay, so it will having authority, and then it will divert it into other servers. Then what we are having is primary servers. Primary servers is about to store a file about a zone at the zone level. We are having at zone level 1, zone level 2, zone level 3. They are having a subdomains, subdomain 1, subdomain 2, subdomain 3, up to n we are having. So we are having authority of creating, maintaining, and updating the zone level. The zone as a we are having a root server have authority to divert it into a secondary servers and the primary servers, but the primary server have authority to create it. If any for example we are having a Google, for example, its address has to be changed 192.170.160.17. It is updating into 18. For example, the IP is updating to it. Yeah, in a recent in a future it will update into a version 6. So that IP has to be changed into it. So all these IPs are updated at a server, primary server, that is on a private server. We will have an authority to create also, to maintain also, and to update at these files have to, because in that files has to be stored into a databases to this. So we are having a primary server that is having is it. The secondary servers, we are having have a transfer or complete information about the zone. They are having an information because there was communication between these servers, primary, secondary, and this. So this is a primary server, and this is a root server, primary server, and we are having a secondary server. So they are coordinating with each others. So we are having information, full information of our primary also, secondary. The root is also having a primary and secondary. So we are having a this of another servers, which is primary and secondary servers. So other server, this is also a secondary server, 2 also, this is secondary server, 3 also, this is primary server, 1 also, 2 also. So they are coordinating with each other because we are using a distributed databases. In a secondary server, we don't have an authority to create update at our zone level. This have authority of the primary server to create an update. The secondary servers have an information that is transferable from the primary to secondary or secondary to primary, or other secondary to secondary also. So these are the 3 servers we are using into a DNS. Okay, so we will see that what are the working of the how the DNS work. The DNS has to be a domain name. We are having a domain name. For example, if you will have to go for a DNS server. The DNS server will see that, okay, www.google.com. We will see it will give a request at www. It will give a IP back to it. So how the IP work to it, all the root servers, primary servers, secondary servers, if they are not saved in a root server, it will saved into cache. It will not saved in cache, it will redirect into a .com server. So .com, it will go for a .com here. So we will see that this is a process how this DNS work. The DNS translate the www, that is the IP, into IP automatically. These are the steps we will use it. The first it will type google.com. We will type at our website, at our web browser, google.com in a browser, and it will ask a local DNS server for the IP address. Here the local server will go for a ISP, that is Internet Service Provider. When a local server doesn't find it, it will not find it. Maybe it was not a local copy. So IP address is request to a DNS name. It will forward the request to a root DNS. First the request will go to a root DNS. So here the request will go to a root server. It will category it, okay, that is .com. So it will go into a .com server, and then after we will see them. And again inquire for the IP to it. If the root divisor reply to a delegate that I don't know about the Google data, it will go for, but it knows the IP of the DNS server, because we are having a www.google.com. I know that google.com, the IP of .google server, DNS server, I will direct it into what? The root server will direct it into a .com dimension. The local DNS will ask for the .com server with the same question. The .com server replies the same, that it doesn't know the IP of this, but knows the google.com. We are not known the .com, but google.com we have touched. So the local copy will answer the same question to a google.com also. So it will go for root to which .com? .com to google.com. Same question. The Google will surprise that IP address is this. This IP address is transferred to the local DNS with our google.com, and then we will request with our IP address of it. Okay, we will get this is a IP address. So before that there was a local DNS we are having. So this is a working of the when we are typing anything and we are getting the address of it. So next is URL. We see that a short form, what is a URL? URL is a referred to a web address which is uniquely identify a document, anything. So this is my URL for a .com. This is a URL which is used to generate a internet technology index page. We will see that. So we have two types of URL, that is absolute URL and relative URL. Absolute URL, we are having a long form of it. It's a long form, we can't use it. But if we want to shorten it, we are having that as a relative URL. So it is a complete address of the resource of the web data, which having a protocol used, server name, path name. We don't know about it. That is behind the picture. So that is a shortened part. That is a shortened part we use into a relative, which is used into a nowadays we are using it relative URL, not absolute URL. But absolute URL is having in which path, which protocols we are using HTTP protocol with this, on this page, with this HTML, we are using it. So HTML is a protocol, this is a server name, and this is a file name we are having it. Other files also we are HTTP, Gopher, we will use it. So relative is a partial, that is shorten URL. Nowadays we are using this. So we are replacing this by a shorten that you will want to this use. If you want to if we are having a example also, when we are creating a Google form and we are having a long path also, a shortened path also. The shortened path, long path is also the absolute also and relative. So we are in nowadays we are using for shortened paths, and this is used by the relative URL. So in the whole of the discussion, we have seen that what is the need of DNS, why we are using DNS, what is the architecture of DNS, how it is working, what is URL shorten, what is the types of URL, absolute and relative. Absolute is the longest one, and the relative is URL. Thank you for the discussion. Jai.